So for this video, I'm just looking at working through examples of solving separable differential equations and using indefinite integrals to do this. The first couple examples giving general solutions, the next two examples will be with particular solutions. So the idea here is I want to keep all of my y's on one side and using multiplication or division get x's on the other. So the only y's I have are in the dy, so it's fine where it is. I'm going to multiply both sides of my equation by dx. So I get dy is equal to all of secant squared plus 2x plus 5. So I do need the parentheses to show all of it is being multiplied by the dx. There's really a 1 in front of the dy. But I haven't undone a derivative yet, so according to the FTC, an integral undoes the derivative. So on the left, in terms of y, what has a derivative of 1? Well, just y. Antiderivative of secant squared is tangent. I have my plus. Antiderivative of 2x is x squared. I have my plus. Antiderivative of 5 is 5x. And then because this is indefinite, I need my plus c. And then I can check this by taking the derivative. If I take its derivative and I start checking this, I get dy dx. Derivative of tangent is secant squared, plus derivative of x squared is 2x, plus derivative of 5x is 5, plus the derivative of a constant is 0. So that checks out. That's right. So then if I go to my next example, I have y's on both sides of the equations. I'm going to want them on the left-hand side, so I'm going to multiply both sides by y squared. So I'm going to have a y squared dy, and I'm going to multiply both sides of by dx to get dx on the other side. But I haven't gotten rid of my derivative yet. So according to the FTC, an integral cancels out a derivative. I have the antiderivative of y squared would be 1/3 y cubed. I'm going to put my plus c on the other side of the equation, so it's okay. Antiderivative of x is 1/2 x squared plus c. But then when I'm solving a separable differential equation, I do need to isolate the y. So I'm going to multiply both sides of the equation by 3. And I'm not going to do a ton of simplifying here, so I'm taking 3 times all of the 1/2 x squared plus c. And then I'm going to take the cube roots, and I don't need to worry about positive or negatives with a cube root of this whole thing. And there is my antiderivative. If I then go to look at some particular solution examples, same idea. So multiply both sides of my equation by dx. There aren't any other y's that I need to move. Again, parentheses are important here because I need to show that everything is being multiplied by the dx. Antiderivative means that I need, or to cancel out a derivative, I need to take the integral. There's really a 1 in front of this dy, so that's a y. Antiderivative of e to the x is e to the x, my subtraction sign. Antiderivative of 6x squared would be 2x cubed, and then my plus c. At this point, I need to know what c is, so I can take the 1, 0, plug that in. So 0 is the y, 1 is the x, and I get that 2 minus e is equal to c. So I can now go ahead and say that y is equal to e to the x minus 2x cubed plus the 2 minus e. And there is my antiderivative. And again, I can take its derivative to check this. So here, dy dx equals x times y. I want to use multiplication or division to move my x's and y's. So I'm going to divide both sides by y and multiply both sides by dx. So I'm going to have 1 over y dy equals x dx. To undo a derivative, I need to take an integral. The antiderivative of 1 over y is going to be the natural log of y. Uh, I'm going to put absolute values around the y part because I need to make sure that the y is a positive value. When I work on finding the c, I'll explain whether I need to keep those or not. But because at this step I don't know whether or not y is a positive value, I need to force it to be a positive value. So I need those absolute values because I can only take the natural log of positive values. Then 1/2 x squared plus c. At this point, this is where this comes in. I can now use this for two things. I can plug it in to find c, but it also shows me, oh, the function we're looking through, the particular solution, already has a positive y. Since y is already positive, I can drop the absolute values. So c is going to be the natural log of 2 minus 1/2. So I can now say that the natural log of y, and I can drop the absolute values on this because from my initial condition, the y's are already positive. I don't have to make them positive. They already are. Is equal to 1/2 x squared plus the natural log of 2 minus 1/2. But now I need to get y by itself to actually solve this and find what is the function that does this. Logarithms are canceling out exponentials, so I'm going to make e the base for both sides, or make both sides, of the equation equal to the exponents for e. So e and natural log cancel, leaving y. And on the right-hand side, e to the 1/2 x squared plus the natural log of 2 minus 1/2. I could simplify this using powers of exponents and logarithms, but I don't have to. So that is my antiderivative.